I'm going to show you the footage I got with my Nikon P900 that I shot from Bridgeport, Connecticut, more exactly in Lordship, little peninsula sticking out here. And as I was innocently looking across the Long Island Sound, panning towards New York City, I was surprised on that day to see what I saw. Let me show you a little closer. Can go in a satellite image here, make it look a little natural. Get a little closer look where I was. Hey, didn't I press satellite here? Here we go. So see, I was standing right out here on the Lordship seawall by Stratford, Bridgeport. 3D image. Let's spin her around. Closer. Oh, it's right over here. Sorry, be so slow. Okay, Stratford seawall. You see it right over here. A little closer look. So as you can see, the seawall right here, parking lot, the sand of the beach walks right up there. It's right above, we could say, sea level. Let's do some three-dimensional spin around. See all the big boulders there. They're like emerging out of the water. And you can see barely any slope coming out of the water. The sidewalk is probably 5 feet over the water. And the camera eye, as I was standing on the sidewalk, must have been approximately 10 feet over the water level. Okay, which is about the ocean level in the Long Island Sound, because there's not much of a difference. There's no slope in between. Anyway, let's check out where I was looking. And I was looking across the Long Island Sound. And I'm going to show you in my video as I'm looking the long way of the Long Island Sound towards New York City. I saw something. I got very surprised. That's after learning about the flat earth. Learning thoroughly about the flat earth. Because I had been an astrologer for about 20 years, so the solar system for me was pretty much in my back pocket until I learned about flat earth. And then I was kind of confused for a while. What's going on? Well, really flat. But if you go out there and make observations like I did, you're gonna see something else. So sorry for all these old guys walking down the streets. They weren't there before on Google Map, but now they are, unfortunately. But just to give you an idea, if you look this way, you can see just a handful of skyscrapers can be tall enough to go over this site. So you see the skyline behind, and you just see a handful of skyscrapers because there are hundreds of skyscrapers in New York City and area. Okay, and let's take a look at those skyscrapers. NYC tallest skyscrapers. All right, what do we have? So the tallest one is the One World Trade Center at 1,776 feet. It's like a sacred number for the Freemasons, must be. And then the Let's look on Wikipedia. They're going to give us a little bit more information that they want us to know. Okay. The list is down below somewhere. See them all lined up. See the tallest ones, but let's look at this list down here. So this one here, the tallest one in New York, okay, its roof height is 1,368 feet. That's the height of the rooftop, but the antenna leads it up to 1,776 feet. Okay, and then the other towers that are next on the list, according to this little asterisk here, they're not finished yet, but they say that most of the height is already there. But when I took my shot, that was in 2018. I don't know if they were being built back then. Anyway, so we have the 432 Park Avenue, which is what, doesn't say. Oh, 13 here, 1396. So it's actually taller than the One World Trade Center at the rooftop. Okay, so it's One World Trade Center is not the tallest, but if you stick an antenna up there, then you're gonna beat the 432 Park Avenue. And then you get 1268 feet, and down the Empire State Building, 1250 feet, and lower. So we won't even consider the shorter ones. Okay, so that's what we get. So basically, the tallest buildings are around 1,400 feet. Okay, this one's gonna be pretty tall when they're done. Central Park Tower. Central Park really need a tower? Anyway. But if we look on Google and we want to picture ourselves in the world, okay, according to Google and a bunch of scientists, the world is a ball, okay? So in order to calculate the curvature, first we need to know the radius of the Earth, which is 3,965 miles, okay? It's not more than that, it's not less than that. It's not 4,000 miles, it's not 3,900 miles. Okay, you get this point here? So numbers here are precise. And by using the Pythagorean theorem of a squared plus b squared equals c squared, it gives us 7.98 inches per mile, which is approximately 0.88 inches, 8 inches per mile. And we have to square that number, okay? So if you want to take time to read all this, I'm not going to waste your time too much, but if your eyes are much faster than mine to read, you can see that they explain it very well. You know, if you're not so good in math, you can have somebody else explain it to you. But I'm going to skip this step right now. So basically, the formula, did they even put it on there, the formula, how to calculate the globe here? No, let's see it. So it's 8 inches per mile squared. That's what is the formula. Okay, 8 inches per mile squared. So the distance of sight is how many miles we're measuring, how many miles away we are from what we're looking. Okay, and then we should be able to see in height what is available according to the curvature of the Earth, curvature of our round ball Earth. Okay, so if the Earth is a ball and the people say the Earth is flat, so we have two opposite realms here, flat or round. Two choices, okay? Is there another choice? Is there another option for the world we live in? Let's see. Let's see at the elevation in New York. What's the elevation on the New York Manhattan Street? Let's go see in here. Can you tell us, please, internet, computer, Lord? 13 feet here, about here. 19 feet, okay, about here. On Long Island, Manhattan, no, that's Manhattan, sorry, 32 feet. Okay, that's higher. If we get higher, 59 feet, okay. Anybody's been to Manhattan know that it's pretty much a flat island. It doesn't have much elevation. So wherever those skyscrapers sit, around those avenues and those streets, they're all on low elevation, on flat ground. There's no hill so much in Manhattan. Might be a bit of a slope here and there. I don't really know the place. Maybe some people could tell me, you're wrong. You have this huge mountain in New York. Okay. All right. So let's look at the map again. Go back to TD, 2D. And we're going to see where we are. Manhattan. Let's get some measurements. Where is that? Stanford. Not Lordship or Bridgeport. Where's Stanford? Fairfield. Bridgeport. So it's here. Bridgeport. Manhattan. Okay, let's take a measurement from Manhattan. Measure distance. 2. Get out of the way. Okay, that's where I want to measure. Get out of my way. Oh, that's not bad. Let's do it the other way around. From here, measure distance to Manhattan. We get 55 miles. Okay, plus or less, more or less, plus minus 55 miles. Okay, 55 miles. Oh wait, 55 miles, and how much elevation do we have? I got 10 feet here, and there's 50 feet under those skyscrapers. We plus or minus, more or less. Okay. So calculating the curvature of the Earth. Let's take a calculator. Bing. Okay, 55 miles. We square that number times itself is 3,025. Okay, it's easy. We multiply that by 8 inches to the foot. 8 inches to the foot, 8 out of 12 is 2/3. So I'm multiplying that by 2/3, which is 0.66666, equals 2,016 feet. Okay? Am I right? 8 inches out of a foot is 0.6666 periodically. Okay? Or we could even be more precise. Oops, sorry. It was 7.98 inches to the foot. Oh, it's pretty much the same number, 0.665. Okay? I lost it again. So we had 55 miles. We square that number, 55 times itself. We still get the same number. We multiply that by 0.664, be generous. So we still have 2008 feet of skyline. So we shouldn't be able to see anything below 2008 feet at 55 miles away. If the distance is shorter, we shouldn't be able to see more than a little bit less than 2008 feet. As we get closer to our image, we should be able to see tall things sticking out, but in a far distance, according to the globe Earth's calculation, we shouldn't be able to see anything below 2008 feet. All right? So let me show you the real stuff here. Real stuff. From a camera's eye. Okay, you can see you can recognize the seawall here in Lordship, Connecticut. And I'm looking across there, which is straight across is 10 miles. But the distance varies how far away we get from shore to shore. So as I'm looking out west out there, so you see right here, let's move this out of the way. You see this here, trees, no more trees. And right in front of it is what we could call the curving water, the curvature. Water is curving, and my camera eye here is just above, it's about 10 feet over the water. Okay, I don't want to get my camera wet. I don't bring it down in the water. Expensive Nikon P900. If you want a better camera, there's a Nikon P1000 out there. So I'm looking across, but I want to show you looking towards all the way across towards New York City as I was panning from north to south. Oops, went a little too far here. Just want to show you. Okay. Get this out of the way. Okay, I'm looking for more. Looking out there. But I wasn't looking for what I'm going to show you. I was actually surprised to find what I saw. I was actually trying to see what was on the other side as much as I can, get some footage. That was my goal of the day. It was kind of hard to see what I was looking because the sun was bright in my eyes. I like to wear sunglasses, so I just absorb the sunlight through my eyeballs and infect my brain with all these solar. Oh, what we got here? You see the land ends. The land ends over here. Okay, as we're looking over the water, and if you remember the map we've seen earlier, Long Island is not much of an island. There's not much water separating it from Manhattan. But it is an island. But we shouldn't be able to see that much wide water across if the earth was flat. If the earth was flat, we would be looking at land all the way around the shoreline of the Long Island Sound, looking south, looking towards New York City. I'm sorry I wasn't too steady with my tripod, but here, whoa, we just passed it. Sorry, it's a not so easy thing to do, filming. Okay, you see this? It could be a boat far away. It could be a guy holding a fishing pole up in the air. But to me, it looks like a spire. Yes, a spire from an Empire State Building, maybe? I'm not sure. Let's keep going. But I couldn't even see that at the moment. I didn't see it. That's why I keep going. Look, there's another little thing here we just missed. Again, too far. Is that the same one? That is the same one. Okay. I think I saw another one go by. Oh, here's another little piece here of something sticking straight up. Would the boat be sticking up like that? Oh, and that one, I didn't miss it. I said, whoa, what do we have here? It looks like a skyscraper. I've never seen a boat look like that. You can see two walls, two sides of it. Clear corner here. You can see the rooftop line and a blur of the atmospheric refraction. But would the refraction of the air bend the image of the curvature over the water? I don't think so, because you can see that the image doesn't wobble much more than that. It's just a tiny bit of moisture in the air, because if there were more moisture in the air, I wouldn't see that. The view wouldn't be as good. So I'm panning out for everybody to see that I'm not faking anything here. I don't have the skills to Photoshop. I could have hired somebody, but I'm an honest person. And my heart thrives on the truth. And that's what I'm showing you here. We're not living on a globe. We're not living on a flat earth, because we can see this piece of skyscraper sticking over the curved water, okay? And if we were on a globe, we wouldn't be able to see anything below 2,000 feet, 2,008 feet. And this skyscraper, it doesn't look like the One World Trade Center, which is just under 1,400 feet at the rooftop. So it's a shorter building than that one, and we see a whole lot of it. We see, you see the width of the building here, like 3 times over the water. Okay? So I was kind of in a hurry because I have 5 kids and lots of things to do in one day as I'm visiting my in-laws. It's not my home in Connecticut. And the day is young. So I'll just show you what I saw the next day. Next morning, same spot. See, the water is more calm, and the air is more crisp. I'm looking straight across here. These are the Northport smokestacks on Long Island. Okay, and again, I was looking, but this time after seeing what I saw the day before, I was more curious and more going straight to the point. And I made another video of these guys here, the Northport smokestacks. Okay, and to calculate the curvature we have in front below those buildings here. I have a whole video on that. Please watch if you're interested in knowing what kind of world we live in. Okay, boats. So I was going from north to south again. Oh, too far. Right. So we're coming to the end of the trees out of sight here, over everything beyond the curvature we can't see right now because it's too far away. And we should be able to see it if the world was flat. Should be able to see all the way to New York City without having all this water at the top of our site here. But there are some tall things in New York City. Everybody knows. And these things, whoop, There's one here. What is that? It looks square, kind of, doesn't it? You see the early morning sunrise hitting those windows. Is it a boat? I think it's a skyscraper. You can kind of see. Oh, what's that? Something appearing. Maybe a boat floating in front of it. Fishermen. The door, their poles up. Let's move this thing out of the way. Okay. Sorry to be slow here, but we're gonna move along. Move along, please. I don't want to press anything because I don't want to skip anything and miss it. Thank you. Moving. Boat. Splashing water right at the top of the curvature. Making waves. You think that this theory would make any waves? Oh, this guy just came up with the idea that the world is not flat and it's not a globe either. But it's not new. It's not a new idea at all. Orlando Ferguson, back in 1893, drew a map of what he figured was our Earth. Just by reading the Bible and probably by looking at other maps, such as the Gleason's map that came out the year before. Not Jackie Gleason. Gleason was an admiral in the British Navy. So as an admiral, you have a lot of people going around taking measurements and bringing those measurements to your knees and saying, this is what we got as an Earth. And Gleason made a map as precise as he could get it, because he didn't want to lose any fuel, lose any time while he was sailing across long oceans to get from one place to another. He made sure to make an accurate map. He says it's as is on his map. I'll show you that map some other time. Just telling you about it right now as we're waiting for something to appear. It's like a fisherman. Where's our fish? Gonna be waiting here all day. No. Sorry, not all day. Just a few minutes. Be patient. Enjoy the view. Just wish you were there in Lordship, Connecticut, by the ocean. It was a few days before the 4th of July. What do we have here? What do we have here? You see this glaring piece of architecture? Oops, sorry. You see it? Right here. Looks like it could be a skyscraper from New York City. Or two. Okay. We see it, we can still see it as the waves move along, as the atmospherical refraction is making his walls wobble in our sight. Okay, we can see that it's there and it's not distorting. It's not a bending image like we see in underwater. Okay, we can go a little further, panning out. Whoop, here's another one, here's another one. Taller, okay, almost as high as this here. It might be the building I saw the day before. The day before I saw more of a silhouette. This time I see more of the glaring morning light. Keep on going. Oh, this one is pretty bright, isn't it? You can see the image is getting mirrored out by the flattish water. You can see clearly the antenna. Okay, so if the atmospherical refraction would bend the image over the curvature of the Earth, you think it would leave the antenna that's straight up and the walls that's straight up? Oh. But no, we can actually see the atmospherical refraction. Since it's gas, just like a fart, it just floats in the air. It's a bunch of tiny little molecules bumping into one another. And in the cool morning like that, there's not much heat coming off of the water to distort the image like we would see over pavement. But we are in July on this video. So people are going around in bathing suits. It's warm, but in the early morning, there's not that much heat coming off the water. Okay, have we seen it? Haven't we? That's about all I could see that day. And I went back a few more days after, and I could not get a clearer image that I did on that day. Movie number 322, which is it's an absolute coincidence. I have nothing to do with this skull and bone number. Well, thank you for paying attention. So let's figure it out. What kind of world do we live in? Thank you and aloha.